Today we're doing compound inequalities day 2, and today we're going to focus on absolute value inequalities. So just a refresher, we've talked about this in chapter 1. Absolute value is when you're talking about the distance from 0. And when we talk about the distance from 0, if I have the absolute value of 5, that equals 5. And the absolute value of -5 is also 5. So we are always going to have two answers for this. So some key parts is that the absolute value symbol must be isolated, and the number that's on the opposite side of the absolute value must be greater than 0. It must be 0 or higher. So for example, one that you might see is the absolute value of 2x plus 5 is greater than or equal to 6. And this number right here is the one that has to be greater than or equal to 0. So let's start with this first example. It says the absolute value of x minus 7 is less than 13. That number, 13, greater than 0, so we can go ahead and get started. So remember what we did in chapter 1 is we always made two inequalities. So the first one I'm going to write is exactly how I see it, of x minus 7 is less than 13. The other one that I'm going to write is x minus 7, exactly the same thing, but I'm going to flip the symbol so it's greater than, and then I'm going to do negative 13. And now I'm just going to solve. So I'm going to add 7 to both sides, and I get x is less than 20. And on the other one, I get x is greater than negative 6. So let's go ahead and graph this. So when I graph this, I'm going to do negative 6 on the left, 0 in the middle, and 20 a little farther away. So for x is less than 20, I would do an open circle shaded to the left. And for x is greater than negative 6, open circle shaded to the right. Now notice, remember we talked about and or inequalities yesterday. This is an and because I'm looking for that overlap. So I'm only going to include this middle area. So my final graph is going to have the two circle with just the shaded in between. So I need to write my final answer as an and inequality. So I'm going to do negative 6 is less than x, which is less than 20. That's my final answer. One hint that you can use is if you look at your original inequality statement. This, anytime that it's less than or greater, or excuse me, less than or equal to, it will always be an and statement. So let's go ahead and try this second one. I have x plus 4 is greater than or equal, the absolute value of x plus 4 is greater than or equal to 8. So I'm going to make my two inequalities. I'm going to have x plus 4 is greater than or equal to 8. And my second one, x plus 4 is less than or equal to negative 8. And I'm going to solve. So I'm going to add a negative 4 to both sides. So the first one I get is x is greater than or equal to 4. I'm going to do the same on the other one, and I get x is less than or equal to negative 12. So now I'm just going to put these both on a graph. So I'm going to do negative 12, 0, and 4. For both of them, they're going to have a closed circle. For x is greater than or equal to 4, closed circle shaded to the right. for x is less than or equal to negative 12, closed circle shaded to the left. Go ahead and looking at this graph, this is an or, so I'm going to write the word or in between. So this is my final answer with my graph. Just like the last one, you have a hint. If you have greater than or equal to, this will always be an or statement. So let's try one more. We have the absolute value of x plus 7 is less than or equal to 2. 2 is greater than 0, so we can go ahead and start and solve it. I see that less than. That's my clue. So this right here is telling me that we are going to have an and, less than. So I'm looking for that overlap or what they have in common. So first I'm going to start off by making my two inequalities. So I'm going to go x plus 7 is less than or equal to 2. And the second one will be x plus 7 is greater than or equal to negative 2. And now let's just solve. So I'm going to add a negative 7. And for the first one, I get x is less than or equal to negative 5. Add a negative 7 to the other one. X is greater than or equal to negative 9. Remember I said it's an and, so I need to write this as an and inequality. So I'm going to write the smallest number first, negative 9 is less than or equal to x, which is less than or equal to negative 5. So there is the first part of my answer. Now I just need to graph it. I'm going to do negative 9, negative 5, and I'll put my 0 here. Both are going to be closed circles with this inside shaded. That's my final answer. So let's try this one. The absolute value of 8x minus 11 is less than 0. Now the first thing that I've always checked is this value. And remember we said it has to be greater than 0. Since there's that no equal sign here, absolute value, our distance can't be negative. So our final answer is no solution. And we can write because it cannot be less than 0, or because distance is not less than 0 or a negative number. So that one we are finished with because can't go any farther. Alright, so let's try this last problem. We have 4 times the absolute value of 2x minus 5 plus 1 is greater than 29. So remember, if you go back to the beginning of the notes, the first thing that I said is that we first have to isolate absolute value. So in order to do that, I see that we have a 4 on the outside and a plus 1. So if I'm thinking of inverse, the first thing that I'm going to move is that 1. So I'm going to start off by adding a negative 1. So my new inequality is 4 times the absolute value of 2x minus 5 is greater than 28. Again, it's still not isolated. So the next thing I need to do is divide by 4. So my absolute value now says the absolute value of 2x minus 5 is greater than 7. I gave you that hint. Stop and look at your absolute value. It's greater, so this is going to be an or statement or an or graph. So we're just looking for either answer. So let's go ahead and break it apart. And let's find our two inequalities. So the first one I'm going to have is 2x minus 5 is greater than 7. and the other one is 2x minus 5 is less than negative 7. So let's go ahead and let's solve this. So the next thing I'm going to do is add 5 on all of them. So my new inequality, 2x is greater than 12, and 2x is less than negative 2. Divide by 2 on all of them. So I get x is greater than 6, and x is less than negative 1. And as we said at the beginning, this is an OR statement. So I'm going to write the word OR in between. There's my first answer. So the last thing that I have to do is make my graph. So on my graph, I'm going to do negative 1, 0, and 6. They are both going to have that open circle. X is greater than 6, pointing to the right. X is less than negative 1, pointing to the left. So those are my two answers. So the first thing I did was isolate absolute value, and then I went to solve, and then I graphed. So make sure you have those written down.